Hello surveying students, this is John Hannon, and I'm going to go over a practice problem from chapter 3 in the textbook, number 10A. So it says, solve the following right triangles. So that's the key, right triangles, for the parts not given. And they give us two variables or two parts. They give us an angle, 42 degrees, 23 minutes, 12 seconds, and the hypotenuse, 437.25 feet. And the way I go about doing it is I have to draw pictures for myself. So just so we know, a right triangle gives us one of the variables, and the little sign right here indicates 90 degrees. So this side, the height and the base are perpendicular perfectly, which makes a 90-degree angle. And the angles are in our book, the methodology is the A is here, angle B, capital C for this angle. So the angles are capitals, and the sides opposite the angles are lowercase letters, which are the same. So angle capital A, the side opposite is small a, so that's a length or a distance. Opposite B, angle B, opposite side, small b, C, and in this case C is the hypotenuse. So I think they give us the hypotenuse length, and that is C. Alright, so it helps me to write down what they've given me and what I need to solve for. So they've given us angle A, and hypotenuse is side C, and we need to solve for the rest. Angle B, side A, side B. So the first thing I do, a little easier with a right triangle, is I know two angles. I need to solve for the third one by adding them up and subtracting from 180 degrees, because all the angles in a triangle equal 180. So I take 90 degrees plus 42, and the way I type it into this calculator, one I have here, I go 90, and then I say plus, where's it at? I'm not using my keyboard this time. 42.2312 equals, and I get this number. And if you're using the calculator like I showed in a separate video, the calculator that's built into the operating system, Microsoft operating system, I have to convert this. So I take this and I go inverse degrees, and I want to subtract it from 180, and I inverse degrees it, and I get something. And now I have to hit DMS, and that's my answer. 47 degrees, 36 minutes, 48 seconds. Alright, so now we've solved for B, angle B. And that is kosher with the answer in Appendix F. So now I need to solve for the sides, small a and small b. And the way I do this, you may have your own way by now if you've been practicing. This is the way I remember the basic trig functions when I'm messing with triangles. First thing I do is I write them down in a list alphabetically. Okay, sounds crazy, but that's what I do. So cos, sine, and tangent. Once I have those listed, I write down these ratios here: AH, OH, and OA. And the way I remember that is a happy old heap of apples. Hey, it works for me. I'm not a math genius, but I've remembered it for years. So the functions listed alphabetically: a happy old heap of apples. So if I want to solve for A right here, I know this angle, we were given that, the 42 degrees 23 minutes 12 seconds. Then I look at what I have, what I'm given, so I draw myself a picture here. And I know that sine is opposite over h, hypotenuse. That was also given, so this one's easy. I can solve A with what we're given. So if I take the sine of the given angle, that's opposite over hypotenuse. Whoops, I'm at the wrong place. Equals A over 437.25. That's C, or the hypotenuse. And if I multiply both sides by this denominator here, 437.25, it cancels this out, isolates A. So 437.25 times sine of the angle equals A. And the way I get that with the calculator, clear my entries, I go 437.25 times, and then I put in the number, the angle, 42.231. Whoops. Can I backspace? How do I backspace? Yep, did it with my keyboard. Don't know how to do it up here. 2312 inverse degrees and then sine equals. There's my answer. Don't have to do anything with the answer. I just have to convert the 42 degrees 23 minutes 12 seconds to inverse degrees before I apply the sine function and multiply, and I get 294.76. That solves for my opposite side. And I do virtually the same thing for B using sine opposite over hypotenuse. So I hope this was helpful. Thank you very much.